So let's see some set notations and its corresponding Boolean algebra notations. So you should be able to convert any set notation to Boolean algebra as well as the Boolean algebra notations to set notations. So empty set, the set notation is 5 and the corresponding Boolean algebra notation is 0. Similarly, the universal set, we will represent it as U, capital U, and the corresponding Boolean algebra notation is 1. Now, complement of a set. What is complement of a set? If A is the set, then complement of A is all the elements in the universal set which are not in A, right? So the complement of a set is usually represented as a complement like this, and in Boolean algebra we will represent it as a complement. Okay. Similarly, set union. If you have A and B, two sets, then the union will be A union B, and the corresponding set notations will be A plus B. Similarly, intersection, that is A and B, right? So you say that A intersection B is a set of elements X such that X is an element of A and X is an element of B, right? So the notation is A intersection B in set notation is like this, and the corresponding Boolean notation will be AB. That is A and B, right? Now set difference, that is A minus B. That means A minus B is the set of elements X such that X is an element of A and X is not an element of B, right? So we can write it as X is an element of A and that is intersection. X is not an element of B, that is A intersection B bar, right? So A minus B is nothing but A intersection B bar. So the corresponding Boolean algebra notation will be A B bar. Then symmetric difference, that is A XOR B, right? So this will be the notation. So this is nothing but A XOR B. So that will be equal to A B bar plus A bar B. And subset, we say that A is a subset of B. Will be representing like this, right? What it means is you have, or we can say that A is a subset of B means A is a subset of B means if X is an element of A, then it should be an element of B, right? X should be an element of B, right? That is meaning of A is a subset of B. So we can write if X is an element of A, then X is an element of B, right? A implies B. So we know that A implies B is equal to A bar plus B. So this should be always true, right? This should be always true. So this should be equal to 1. Okay. Or I can say that, for example, if you have Venn diagram, then if I know that A, this is A, and let's assume this is B, then I can say that A is a subset of B, right? So what I can say that if I take A bar, this A bar, right? Then A bar, then union B, A bar union B, B is this one, right? That will be equal to universal set, right? So that means A bar union B is universal set means A bar plus B should be equal to 1, right? So this is the subset notation. We have A bar plus B is equal to 1. Now let's see some of the gate problems that we can solve using this idea. Let A and B be the sets, and let A complement and B complement denote the complement of the sets A and B. The set A minus B union B minus A union A intersection B is equal to, so we have to find out set corresponding to this expression, right? So A minus B union B minus A union A intersection B, right? So we know that A minus B is A B bar, union is plus, B minus A will be equal to B A bar, union, that is plus, A intersection B, that is A B, right? So if you see these two terms, A B bar and A B, I can add A to this, because the difference here, if you see, the difference here is only 1 liter, that is actually becoming the complement of the other. So that means I can add A to this expression, right? So if I add A to this expression, this is called the consensus theorem. So if you have some variable, for example x, y, z bar, and here you have something like x, y, z, then that means if you see these two terms, the only difference is 1 liter is getting complemented. If only 1 liter is getting complemented, then the remaining terms, that is xy, you can add that here. So that is called consensus theorem. Or if you have an expression like this, you can remove this xy from this, still it will be same. Okay, so I added a. Now I have a and ab, so I can cancel this, because if you see a plus ab is nothing but a into 1 plus b, right? 1 plus b will be 1, so the answer will be a. So if I have a term that is having less number of literals, and this other term with more number of literals, then I can remove that, right? So here again I have a b bar, I have a here, so I can remove this one also. So I am having a plus a bar b. Now if you see, I have a here and a bar here, so the remaining term is b, so I can add b. Now I can remove this one, because I have b here and b here, right? So I can remove this. So I am getting a plus b, that is nothing but a union b. So the answer is a. Let a comma b and c be the non-empty sets, and let capital X is equal to a minus b minus c, and capital Y is equal to a minus c minus b minus c. Now which of the following is true? So we have 4 options: x is equal to y, x is a subset of y, and y is a subset of x, or none of this. Okay, so let's see what is x. X is nothing but a minus b minus c. So what we know that a minus b is equal to a intersection b bar, right? So a minus b will be a intersection b bar minus c, right? So that will be equal to a intersection b bar, right? Then I have c here, that will be intersection c bar, right? So I can write this as a b bar c bar. Now let's see what is y. Y is nothing but a minus c, that is a c bar, minus b minus c, that is b c bar, right? Now I have to do again one more subtraction, right? So that will be equal to a c bar intersection b c bar all bar, that will be equal to a c bar into b bar plus c. So first term, if I multiply a b bar c bar, second time I have c bar here and c here, so if I multiply, that will be 0, right? So I am getting y is equal to a b bar c bar. X is also equal to A, B bar, C bar. So the answer should be X is equal to Y. Let P, Q and R be the sets and this triangle denote the symmetric difference operator defined as P symmetric difference Q is equal to P union Q minus P intersection Q. So what is P symmetric difference Q? That is equal to P plus Q minus PQ, right? That is equal to P plus Q intersection PQ all bar. So that will be equal to P plus Q into P bar plus Q bar. So that will be equal to PQ bar plus P bar Q, right? This is the XOR operation. Now let's see the choice 1. So in the left hand side we have P, let me write this XOR operation, P XOR QR, right? P XOR QR. So that will be equal to PQR all bar plus P bar QR, right? So this will be equal to P into Q bar plus R bar plus P bar QR. Here we will be getting PQ bar plus PR bar plus P bar QR, right? So this is the left hand side. So let's see the right hand side. In right hand side we have P XOR Q into P XOR R, right? So we can write this as P XOR Q will be P Q bar plus P bar Q into P XOR R will be P R bar plus P bar R. So I will get P Q bar R bar plus P bar Q R, right? So these two equations are not same. This is not same, right? So this choice is wrong. Now let's see the second choice. So it says you have PQR, that is the left hand side, right? You have PQR, that means if P is equal, this will be true when P is equal to 1, Q is equal to 1 and R is equal to 1, right? All other conditions, this will be false. That's the meaning of PQR, right? Now let's see the right hand side. It says P intersection Q XOR P XOR R, right? And we need to see these two are equal, right? So P intersection Q is nothing but PQ XOR P XOR R, right? Okay, so you don't need to evaluate further because we know that this expression will evaluate to 1 only if P is equal to 1, Q is equal to 1 and R is equal to 1, right? For example, if P is equal to 0 and Q is equal to 1 and R is equal to 1, this expression is going to evaluate as 0, right? Now let's see what happens here with the same values. P is equal to 0, Q is equal to 1 and R is equal to 1, right? So PQ will be 0 into 1, that will be 0 XOR P XOR R, P is 0 and R is 1, so P XOR R will be 1. Now 0 XOR 1 will be equal to 1, right? So for this assignment, P is equal to 0, Q is equal to 1 and R is equal to 1. This left hand side evaluates 0, but the right hand side evaluates 1. So this option is also wrong. See, if you want, you can actually expand this further and find the exact Boolean expression. I just stopped here because it looks different, so I just substitute with some values. Okay, so the answer is neither 1 nor 2. Let E, F and G be the finite sets and let X is equal to E intersection F minus F intersection G and Y is equal to E minus E intersection G minus E minus F. Which of the following statement is true? So we have 4 options. So let's see what is X. X is equal to E intersection F, that is EF, minus F intersection G, that is FG. So we know that EF minus FG should be equal to EF intersection FG complement, right? That means this is equal to EF into F bar plus G bar. So I'm getting EF G bar, this X. Now let's see what is Y. Y is equal to E minus E intersection G, that is EG, minus E minus F, that is EF complement, right? So here I'm getting E minus EG, that is E intersection E complement, sorry, EG complement, right, minus EF complement. So here it will be E into E bar plus G bar minus EF bar. So I can say this is equal to E G bar minus EF bar, right? So this I can write it as E G bar intersection EF bar whole bar. So that will be equal to E G bar into E bar plus F, that's equal to E G bar F, right? So we are getting the same expression in both sides. X is also equal to EF G bar and Y is also equal to EF G bar. So the answer should be X is equal to Y. If P, Q, R are subsets of the universal set U, then P intersection Q intersection R union P complement intersection Q intersection R union Q complement union R complement is. So we have an expression here, and we have to find out the what this expression is going to get evaluated, right? So P intersection Q intersection R, that is P Q R union, that's plus. Then I have P bar Q R plus Q bar plus R bar, right? So I have R bar here and I have R here, so I can add PQ, right? If I add PQ, I can remove this PQR. Now I have Q here and Q bar here, so that means I can add P, right? So I can remove this PQ, right? Now I have P here and P bar here, so I can add QR, right? So I can remove this. Now I have Q here and Q bar here, so I can add R, so I can remove this one. Now if you see, I have R here and R complement here, so if I add R plus R complement, always this is going to get valued as 1, right? And we know that 1 plus something is going to be 1, and 1 is equal to universal set, so the answer should be D. We have two statements here, S1 and S2. We had to find out which of the following is true about S1 and S2, right? So first statement says there exist infinite sets A, B and C such that A intersection B union C is finite. So you cannot convert this into Boolean expression and solve this. We are asked to find whether A intersection B union C is finite, right? Is it possible like that? Okay. So let's assume A is a set of all binary strings ends with 0, and B is the set of all binary strings ends with 1, and C is the set of all binary strings ends with 1. Okay, so these are all infinite, right? Now we had to find B union C, right? So what is B union C? B union C, B is set of all strings ends with 1, and C is set of all strings ends with 1 1. But we know that C is actually a subset of B, so B union C will be equal to B, right? Now if you then we had two intersection, right? So what is A intersection B union C here? Here A intersection B union C is nothing but A intersection B, right? Now uh, A is all binary strings ends with 0, and B is all strings ends with 1. So if I take intersection, none of these strings will be common to both these sets, right? So that will be equal to 5, and which is finite, right? Now the statement S1 is correct. Now let's see the second statement. There exist two irrational numbers. What is irrational number? A irrational number is a number that you cannot write in a simple fraction format, right? So two irrational numbers x and y such that x plus y is rational. Is it possible? Yeah, it is possible. For example, you can take x is equal to 1 plus root 2, which is irrational, and y is equal to 1 minus root 2, which is also irrational. Now if I add x plus y, I am getting 2, which is a rational number. So both statements are true. So answer should be C. So before proceeding further, let's see what is binomial theorem and the connection between binomial theorem and subsets, and what is a power set. Okay, so we'll see those terms first before proceeding with the next questions. So the binomial theorem says if you have a plus b all raised to n, this is equal to sigma of r is equal to 0 to n c r a raised to n minus r e raised to r. So this is what the binomial theorem says. A plus b all raised to n is equal to sigma of r is equal to 0 to n ncr a raised to n minus r b raised to r. So let's let me ask you, for example, if you have a plus b all raised to 5, what will be the coefficient of a square b cube? What will be the coefficient of a square b cube? So actually in the expansion, right, we know that the first term will be a raised to 5 b raised to 0, right? We are, let's leave the coefficient, and the second term will be a raised to 4 b raised to 1. This is very easy, right, because we know that the sum should be equal to 5, right? So here it will be a cube b square, then we will have a square b cube, then we will have a raised to 1 b raised to 4, then we will have a raised to 0 b raised to 5, right? So we have to fill the coefficients. Okay, so let's see what will be the coefficient of a square b cube, right? So we have a plus b, so we have somehow multiply this a plus b into a plus b into a plus b into a plus b into a plus b. That is what is a plus b all raised to 5, right? And we need to get the value a square b cube, right? So how many different ways you can multiply this to get this a square b cube? That will be the coefficient, right? So that means I have to select 3 b's from this 5, right? For example, I can select a b from here, and a b from here, and a b from here. Then I will take a and a from here. So I will get a square b cube. This is one way. So maybe I can take a from here, then I can take b from here, b from here, b from here, and a from here. So that also will give me a square b cube. So there are different ways I can select this. So if I add all these things, I will get the coefficient, right? So how many ways I can select? If I have 5 terms here, So I had to select exactly 3 B's. I don't need to worry about A because once I select B, the remaining should be A, right? So exactly I have 5 terms. In that exactly I have to select 3 B's, right? So 5 C3 ways I can actually select A square B cube. Okay. So now if you see the coefficient here, in this term, right, I have to select exactly 0 B's in this 5 terms. So that can be done in 5 C0 ways, right? Here I have to select exactly 1 B, so that can be done in 5 C1 ways. Here I have to select exactly 2 B's, so that can be done in 5 C2. Here I have to select 3 B's, so that is 5 C3. Here 5 C4 and here 5 C5. Okay, so that is so I can write A plus B all raised to 5 is equal to sigma of C from 0 to 5, right? So R can be from 0 to 5, right? Then 5 CR, right? A raised to, the first term will be 5, then 4, right? So I can write it as 5 minus R B raised to R, right? So this is the expansion of A plus B all raised to 5, and whatever may be the binomial, whatever may be the equation. For example, if you have A plus B all raised to 100 and someone is asking you to find out what will be the coefficient of A raised to 20, B raised to 80, and the coefficient will be 100 C 80. Okay, so remember this. Now using this formula I can find out what is 1 plus 1 all raised to n. Right? What will be 1 plus 1 all raised to n? So that will be n C0 1 raised to n 1 raised to 0 plus n C1 into 1 raised to n minus 1 1 raised to 1 plus n C2 into 1 raised to n minus 2 1 raised to 2 plus etc. up to NCN 1 raised to n minus n 1 raised to n, right? So this term, if you see, that is 1, right? So I can write 1 plus 1 all raised to n is equal to NC0 plus NC1 plus NC2 plus NC3 plus etc. NCN. Okay, so remember this, 1 plus 1 is actually 2, so 2 raised to n is nothing but NC0 plus NC1 plus NC2 plus NC3 plus NCN all raised to n. Now using same idea, what will be 1 minus 1 all raised to n? So 1 minus 1 all raised to n is 0, right? So I can use the same idea here. So NC0, right, 1 raised to n minus 1 raised to 0 plus NC1 1 raised to n minus 1 minus 1 raised to 1 plus NC2 1 raised to n minus 2 minus 1 square plus NC3, right, 1 raised to n minus 3 minus 1 cube plus etc. Right? So if you see, minus 1 raised to 0 is 1, so this will be NC0. Now if you see here, minus 1 all raised to 1 is minus 1, so this will be minus NC1. Next will be NC2, and the next term will be NC3. Next term will be NC4, then NC5. So all the odd numbers will be minus and even numbers will be plus, right? NC6 minus NC7, that's equal to 0. Okay, now I can take all the minus value to the left side. Then I will get NC1 plus NC3 plus NC5 plus NC7 plus etc. will be equal to NC0 plus NC2 plus NC4 plus NC6 plus etc. Okay, so remember these two identities. One is this one and another is this one. Okay, now we'll see what is subsets and power set. Okay, so we know what is a subset, right? So what is a subset? We say that A is a subset of B if X is an element of A, then X is also an element of B, right? So that's called the subset. For example, if you have A is equal to 1, 2, 3, 4, then B can be 5. 5 is a subset of A, right? And B can be 1, 2. This is also a subset of A, right? So the question is, how many different subsets I can create? Okay, so how many different subsets I can create using A? So A is equal to 1, 2, 3, 4. So let me write here 1, 2, 3, 4. Now I have to construct A, right? Sorry, I have to construct B, that is a subset of A. So if you see, right, I can actually keep B is equal to 5. That means I am not selecting 1, not selecting 2, not selecting 3, and not selecting 4, right? Or I can have B is equal to 1. That means I am selecting 1, I am not selecting 2, I am not selecting 3, I am not selecting 4, right? I can have B is equal to 1, 2, right? That means I am selecting 1, I am selecting 2, but I am not selecting 3 and 4, right? I can have B is equal to 1, 2, 3, 4, right? So that means I am selecting everything. So what I am saying is, if you notice, for every subset you can have a corresponding binary number, right? So if you have a binary number 1, 0, 1, 1, then that can represent a subset. For example, that will be you are selecting 1, not selecting 2, you are selecting 3 and 4, right? So there is a one-to-one relationship between these two subsets and a set of binary numbers. So we know that if you have four numbers, right, then you can have 2 raised to 4 different binary numbers, right? So you can have 2 raised to 4 different binary numbers. So subsets also you can have 2 raised to 4 different subsets. Okay, clear? So also one more thing, if you have, also you can say that if you have A is having n elements, then the maximum possible number of subsets will be equal to 2 raised to n. If A is equal to if A is having n elements, then the maximum number of subsets possible will be 2 raised to n. Or you can see this problem differently. For example, let's take A is equal to 1, 2, 3, 4, 1, 2, 3, 4. Then the different type of subsets, you can say that you may have subsets with size 0. That means out of this 4 element, you have to select only 0 element as a subset, and you can have subsets with size 1, right? So how many different subsets are possible with size 1? You have 4 elements, you have to select only 1, right? So how many subsets of size 2 are possible? You have 4 elements and you can select 2, right? Similarly, you can have subsets with 3 elements. How many different subsets are possible with 3 elements? That will be 4C3, right? Then you can have 4C4, right? That is equal to 2 raised to 4. Okay, so if you see, if you assume that you have n elements, then the number of subsets will be equal to nc0 plus nc1 plus nc2, nc3 plus etc. ncn, that is equal to 2 raised to n. So this way also you can think about this. Okay, so one more thing, let's assume you have a set with A is equal to 1, 2, 3, 4. Now let's assume I want to find out the number of subsets with even cardinality. Okay, So I am interested in subsets which are even, okay, having even cardinality. Okay, so I have 4 elements. So the even cardinality, if you see, that will be 4C0, right? 0 is even, plus 4C2 plus 4C4, right? So that will be the even cardinality. And what about the odd cardinality? Odd cardinality. Odd cardinality will be equal to 4C1 plus 4C3, right? So 4C1 plus 4C3 will be the odd cardinality, right? Also, we have noticed in the previous slide that 1 minus 1 all raised to, for example, here 4, 1 minus 1 all raised to 4 will be equal to 4C0 minus 4C1 plus 4C2 minus 4C3 plus 4C4, right? This is 0. So I can say that 4C0, right, plus 4C2 plus 4C4 will be equal to 4C1 plus 4C3, right? So these two values should be equal, right? These two values should be equal. So 4C0, that is equal to 1 plus 4C2. 4C2 is 4 factorial divided by 2 factorial into 2 factorial, right? So that's equal to 2 into 3 into 4 divided by 4, right? That's 6, right? 6 plus 4C4, that's 1, right? So I'm getting 8 here. You see, I have total 2 raised to 4 subsets, that is actually 16, right? So half of them are actually even and half of them should be odd, right? So 4C1 will be equal to 4 plus 4C3, that will be equal to 4, right? So I'm getting 8. Okay, so it shows that the subsets with even cardinality will be equal to subsets with odd cardinality. So we know that total we have 2 raised to n subsets. So half of them will be of even cardinality. So that is equal to 2 raised to n by 2, and that's equal to 2 raised to n minus 1. Right? So 2 raised to n minus 1 subsets will be of even cardinality. Similarly, you will have 2 raised to n minus 1 subsets of odd cardinality. Okay. Now let's see what is a power set. So if you have a set A is equal to 1, 2, then the power set of A, usually denoted as row of A, or sometimes we write it as 2 raised to A, will be the set of all subsets. Okay, that is the set of all subsets. Now what will be the subsets here? That will be 5, then 1, 2, and 1. Okay, so these are the elements in the power set. So if you see that the elements here, for example, this element is not present in the set A, right? Because here this element is a set. Okay, this element is a set, and here it is not a set, it is just an element here. Okay, so here it is just 1 here, so here it is a set. Okay, remember this. So power sets are actually containing the sets. Okay, and it is the subsets. Okay, so one more thing, whatever may be the set A, for example, if the set A is equal to 1, 2, 3. So you have only 2 elements here. Okay, even though it's a set, it is 1 element here. Okay, and this is another set. So you have only 2 elements here, and so the cardinality of the power set will be 2 square. Okay, so always remember this. Okay, so whatever may be your size, for example, if you have n elements here, then your power set will have 2 raised to n elements. Okay, now let's solve some questions. The question is the cardinality of the power set. We had to find the cardinality of the power set. So basically we have to see how many elements are there, right? So we have 11 elements here. 11 elements here, 0 to 10, we have 11 elements. So the cardinality of the power set should be 2 raised to 11, okay, and that will be equal to 2048, right? It will be equal to 2048. So the answer should be C. So we have to find the number of elements in the power set of the set S is equal to some set is given. Okay, so only thing you have to see is how many elements are there in the set. So you have 1, right, 2 and 3, right? So the power set should contain 2 raised to 3, that is 8 elements. So the answer should be C. Let capital A be the finite set of size n. The number of elements in the power set of A cross A. So first we had to find out the number of elements in A cross A, right? So if A is equal to 1, 2, 3, right, then A cross A will be the set of ordered pairs, right? That is A cross A will be equal to set of ordered pairs, that is 1, 1, 1, 2, 1, 3. That means you can actually concatenate, or you can select pairs 1, 1, 1, 2, then 1, 3. Then you can select 2, 1, 2, 2, and 2, 3, 3, 1, 3, 2, and 3, 3, right? So across A will have 3 into 3, that is 9 elements, right? So here you have n elements in A, so across A will have n square elements. Now we have to find out if I am taking the power set of across A that has n square elements, then what will be the cardinality of the power set? That will be 2 raised to n square, right? That will be 2 raised to n square. So the answer should be B. The number of subsets, that we have a set of n elements with odd cardinality. Okay, so we know that if you have n elements, total you will have 2 raised to n elements in the you can have maximum 2 raised to n subsets, and half of that should be of odd cardinality, right? So that should be 2 raised to n by 2, right? So here we'll be having 2 raised to n minus 1, right? So the answer should be 2 raised to n minus 1. So I think there were some choices here that is missed out. So the answer should be 2 raised to n minus 1. For a set A, the power set of A is denoted by 2 raised to A. If A is equal to the set 5, 6, 7, which of the following statements are true? Okay. So we know that the 2 raised to A, that is the power set, should contain 5, right? It should contain 5, then it should contain 6, okay, then 7, then it should contain 5, 6, that is 5, 6, right? It should contain 6, 7, right? So 6, 7. So like that you will have 8 sets, right? Now the first choice says 5 is an element of 2 raised to A. That is true. 5 is an element of 2 raised to A, right? So this is true. And 5 is a subset of 2 raised to A. We know that 5 is a subset of any set. So this statement is also true. Now the third choice says that 5, 6 is an element of 2 raised to A. That is correct. 5, 6 is an element of 2 raised to A. This is true. Now the fourth choice says 5, 6 is a subset of 2 raised to A, right? So what it says is actually 5, 6, right? This is actually a subset of 2 raised to A. Okay, so how can we say that this is a subset of 2 raised to A or not? Okay, let me explain you with a simple example. If I ask whether 5 is a subset of this set, The answer is no, right? This 5 is not a subset of this, because if 5 is a subset of this, that means you need to have the element 5 in this set, right? But you don't have element 5, you have only the element set 5, right? So we say that A is a subset of B if X is an element in A, then X should be an element in B, right? Here X is actually 5. 5 is in A, but 5 is not in B. Okay, but if I ask you whether this set is a subset of 2 raised to A, that is true, because you have the element, that is set 5, that is present here. Okay, so this is a subset of this set, but this is not a subset of this set. Okay, so the same way, if you see this one, we are saying whether there exists an element 5, 6 is present in this set. It is not present. Okay, the element present here is different. That is actually this element, right? So this is not a subset of 2 raised to A. So this choice is wrong. So the answer should be 1, 2, and 3. C. The power set of the set 5. Okay. See, remember there is difference between 5 and the set 5. Okay. Here, this is actually representing a set like this. This does not have any element. So here it is different. It has one element. Okay. One element. One element. Okay. So the power set should contain 2 raised to 1. That is 2 elements. 2 elements. So the power set should contain 2 elements. Right? So the choice A is wrong, choice C is wrong, and choice D is wrong. So the correct option should be B. Let A be the set with n elements. Let C be the collection of distinct subsets of A. Okay, so C is the collection of distinct subsets of A, such that for any two subsets S1 and S2 in C, so you may have some subsets here, okay, because C is the distinct subsets of A. Now, if you take any two sets from here, one is, well, let me call it as S1 and another one is S2, then the condition should be S1 is a proper subset of S2 or S2 is a proper subset of S1. Okay, so this is the condition we should hold, and all the sets should be distinct. Then the question is, what is the maximum cardinality of C? Okay, so I had to include here all the subsets that is actually going to satisfy this condition. Okay, so I can definitely add 5 because 5 is going to be a subset of every set. Right now, can I add 1? Yeah, I can add. Let's assume you have 1, 2 up to n elements. Okay, or maybe for example I can take 1, 2, 3, 4. Okay, so I can add 1 here because 5 is a subset of 1. I have only 2 sets now. Can I add 2 here? This is not possible because if I take 1 and 2, these 2 sets, it is not a subset of other, right? So that means now if I take any other set, I need to have this 1 included there, right? So I can take 1, 2. This is valid because this is a subset of, 5 is a subset of 1, 2, and 1 is also a subset of 1, 2. So I can take any 2 sets from this and apply this condition, right? Now, what is the next one? If I add one more, that should have 1 because it should be a subset of this one. It should be having 2, right? Because that should be a subset of 1, 2, and then 3. Okay, so this is possible. Okay, then I can add one more set, that is 1, 2, 3, 4. So these are the maximum subset possible with 4 elements. Okay, so with 4 elements, you can have 5 distinct subsets, right? So if you have n elements, you can have n plus 1 distinct subsets. The answer should be B. How many pairs of sets A, B are there that satisfy the condition A, B should be a subset of 1, 2, 3, 4, 5 and A intersection B should be equal to 5. Okay, so we can derive a general formula for this question actually. For example, let's assume you have 1, 2, 3, etc. up to n levels. Okay, and the question is we need to have pairs of sets A comma B, right, that satisfy A intersection B is equal to 5. For example, you can have A is equal to 5 and B is equal to 1, 2. This is one example of such pair. Or you can have A is equal to 1 and B is equal to 2. Or you can have A is equal to 2 and B is equal to 1. Right? So, like this, you can have different ways of creating the sets A and B. Right? So, basically, if you see, the idea here is if you take one element, for example, this one, you can keep that element in A, or you can keep that in B, or outside, right? That means you are not interested to keep in both sets A and B, right? So let me call that set as C. So I can say that for one element, I can put it in either A or B or C. C is the outside set, okay? And similarly for 2, I can say that, okay, 2 can put either in A or B or C, right? So every element got 3 choices, right? Every element got 3 choices. So the answer should be 3 raised to n. 3 raised to n. So here the answer should be, we have 5 elements. So the answer should be 3 raised to 5. Okay. Now we can also solve this problem in different way. For example, for a easy explanation, I will take this set. So we have maybe S is equal to 1, 2, 3, 4, 5, right? And for example, I can say that my A set is equal to 5. Let's assume it is 5. That means I am not taking anything to A. Then B, I can have any subsets of S, right? Because A is 5. If I do intersection with B, the answer will be 5, right? So I can take any subset here, right? So B has actually 2 raised to n different ways I can actually create subsets, right? Now, if you see, I can take the element 1, okay? Now, B should not contain 1, right? B should not contain 1, but it can contain the remaining n minus 1 elements, right? The remaining n minus 1 elements, I can create different sets. So how many different sets I can create with the n minus 1 elements? I can create 2 raised to n minus 1 different subsets, right? Similarly, A is equal to 2, I can create B is equal to 2 raised to n minus 1. So basically what I'm saying is, I can actually keep only one element in A. How many ways I can keep one element? If I have n element here, I can have nc1 ways of selecting one element to A. Then B can be, at that time B can be, because I am taking only one element here. So n minus 1 elements are remaining. So I can have 2 raised to n minus 1 subsets. Similarly, I can keep A, right? I can have 2 elements, right? I can have 2 elements. So how many different ways I can select 2 elements from here? I can take in NC 2 ways. So 2 elements are taken to A. Then remaining, I have n minus 2 elements. So I can have 2 raised to n minus 2 subsets in B, right? Now if you see, the formula for that will be NC0, that is selecting A is equal to 5 or A without any element, into 2 raised to n plus NC1 into 2 raised to n minus 1 plus NC2 into 2 raised to n minus 2 plus etc. plus NCN 2 raised to n minus n, that is 0, right? So this is the formula, and this is equal to if you see, I can just rewrite this little bit so that it will be clear to you. I can say that it is NC0 2 raised to n 1 raised to 0 plus NC1 2 raised to n minus 1 1 raised to 1 plus NC2 2 raised to n minus 2 1 square plus etc. NCn 2 raised to 0 1 raised to n, right? That is equal to 1 plus 2 all raised to n, and that's equal to 3 raised to n. So the answer should be 3 raised to n. This is a GATE 2019 one mark question. Let capital U is equal to the set 1, 2, 3, etc. And capital A is a set where you can have the ordered pairs small x comma capital X, where small x is an element of capital X and capital X is a subset of U. Okay, so we have to find the cardinality of A. Let's take an example. U is equal to 1, 2, 3. Okay, and it's given that X is a subset of U. So that means X can take any value that is actually a subset of U, right? So what are the possible values of X? That will be 5, right? Then 1. So you can write all the subsets. So these are the subsets, and X can take any of these values. Okay. Now, what is small x? Small x can take values, right? That value should be an element of capital X. So it depends, right? So if you have x comma x, this is the pair. X can be any of this value, and capital X can be any of this value. So small x only condition is that the right side, if you see the right side is a set. Okay, so the element here should be in that set, right? So for example, I can have 1 comma 1 2. This is a valid representation of small x comma capital X, because only condition is this value, this x should be an element of capital X. Capital X can take any of these values. Okay, now is it possible that can we have small x is equal to 5? It's not possible, right? Because you cannot write 5 is a element of a set here, right? So we don't have a set. We cannot write even 5 comma 5, because 5 is not an element of 5. See, remember this, 5 is representing the set, null set, so it does not have any element. So I cannot say that 5 is an element of 5, right? So small x cannot take the value of 5, but it is clear that small x can take the value 1, small x can take the value 2, and small x can take the value 3, right? These are the only 3 possible values that small x can take. Now, how many different ways actually we can write x comma x, right? That is the question. Now, if when x is equal to 1, the right side should be a set, and only condition is that that set should contain 1. Okay, so if you have u is equal to 1 to n, right? So that means you can have 1 comma, and you have to include 1, and remaining elements, if you see 2, 3 up to n, remaining you have n minus 1 elements. Now if you take 2, you can actually, so I'm just keeping 1 here. Okay, for 2 I can keep it here, or I can ignore it. Similarly, 3 I can keep inside this, I can ignore it. So basically what I'm saying is, you have for this n minus 1 elements, you have 2 choices. So that means keeping 1 here, you can have 2 raised to n minus 1 different subsets in the right side. Okay, maybe I'll explain with this example. So what I'm saying is, for example, you can have 1 comma 1, 1 comma 1 2, 1 comma 1 3, 1 comma 1 2 3. Okay, so these are the possibilities. If you see all this right side, only condition actually the 1 should be present here. Okay, 1 should be present here. right? So in this example itself, you have 1 you are keeping always in the set, so remaining you have 2 comma 3, and using this 2 comma 3 you can actually construct different subset that is actually 2 raised to 2, right? That is 2 raised to n minus 1. Okay, and what I'm saying is you can take this 2 and decide whether to put it here or not, right? And similarly, you can take this 3 and decide whether it should be present in the right side or not. But for 1, you don't have any choice. You have to always keep it in the set, right? So remaining n minus 1 elements, you have 2 choices. So that is 1 into, that's what I'm saying. So you have 2 raised to n minus 1 choices for capital X, and you have small 1. Sorry, when you have 1 here. Okay. Similarly, for 2 also, the same thing happens, right? 2 means right side you need to have, for example, I can write it fast. 2, 2, 2, comma, 2, 3, 2, comma, 2, 1, 2, comma, 1, 2, 3, right? So the right side set should contain 2, and remaining n minus 1 elements, you can choose whether it should be there or not, right? So you have n elements here. If you see, you have n elements here. So that means you, in the left hand side, that is small x, you can have n different values, and in the right hand side you can have 2 raised to n minus 1 values, right? So left hand side you have n values, and right side you can have 2 raised to n minus 1 value. So totally you can have n into 2 raised to n minus 1. Okay, so the option A is true. Now let's see the option B. So what I know is first choice, this is true, right? So if I have u is equal to 1, 2, 3, then the cardinality of A will be equal to, 3 into, right? I have 3 elements here, so 3 into 2 raised to 3 minus 1, right? That will be equal to 12. Now since I know this value is, when n is equal to 3, this value is going to be valid to 12, I can actually try that directly here, right? So this equation, I have sigma of k is equal to 1 to 3, right? K into nck, sorry, 3ck. So that will be equal to 3c1 plus 2 into 3c2 plus 3 into 3c3. Now 3c1 is 3, 3c2 is again 3, so 2 into 3 will be 6, 3c3 is 1, 1 into 3 is 3, so we are getting 12. Okay, so you can even try for n is equal to 4, you will be getting the same answer. So 1 and 2 are true. Okay, so for gate exam, right, this is enough to solve like this. But let's see how can we prove this identity, because it is very important identity. And while proving, right, we will also familiarize with some more properties of binomial coefficients. So let me write that equation again here. We have sigma of k is equal to 1 to n. Instead of k, let me use r so that I can explain it correctly. R is equal to 1 to n, r into NCR, because we usually use NCR, that's why I am using R is equal to 1. Okay, R is equal to 1 to n, R into NCR is equal to n into 2 raised to n minus 1. This is an important equation. So let's see some of the properties of binomial coefficients. So we know already that NC0 plus NC1 plus NC2 plus etc. NCn is equal to 2 raised to n, right? This we already know. So similarly, if instead of n I can give n minus 1, then n minus 1 C0 plus n minus 1 C1 plus n minus 1 C2 plus etc. n minus 1 C n minus 1 will be equal to 2 raised to n minus 1. Okay, because instead of n in this equation we are substituting n equal to n minus 1, so the answer also will be 2 raised to n minus 1. Okay, now let's see another property. It's called Newton's identity. So So let's see a problem. Let's assume you have 12 members, and we want to have a we want to select 5 members from this to form a committee. So 5-member committee, and out of these 5 members, we want to select 2 members as leaders. Okay. So how we will do that? So it is very simple. We know that 12 members are there. Out of that, we had to select 5 members. So 12 C5 into. Now from these 5 members, I had to select 2 as leaders. So 5 C2. Right? This will be the answer. So you can do this problem in a different way. For example, you have 12 members. So you first select 2 leaders. That can be done in 12 C2 into. Now you already selected 2 leaders that are part of the committee, right? So remaining 3 members you have to select the committee, right? So you have remaining, you have 10 members because you already selected 2 members here, right? So remaining 10 members you have to select 3 members, right? Because in this 5-member committee you have already taken 2 members and they are elected as leaders now, right? So this is also true, right? So 12C5 into 5C2 is actually equal to 12C2 into 10C3, right? So these are 2 ways of thinking about solving this problem. So that means I can say that instead of 5 members, if I write R members, and instead of 2 leaders, I can, if I say that K leaders, then this will become, right, instead of 12 members, let's assume I have N members, then this will become NC. First I had to select R members in the committee, so NCR into, from that R I had to select K of them as leaders, so NCR into RCK, that is equal to, right? So another way of doing this is, from the N members I can select K leaders, right? Now K leaders are selected, so remaining members are N minus K, right? From this N minus K I had to select, I cannot select R because already K are selected, so R minus K, right? So this identity is known as Newton's identity, that is NCR into R into, sorry, NCR into RCK is equal to NCK into N minus K into CR minus K. Now if you substitute K is equal to 1, or the case you want to have only 1 leader, you substitute K is equal to 1. So this equation will be RC1, that will be R, right? So R into NCR is equal to, you are substituting K is equal to 1. So NCK will be N into N minus 1 C R minus 1. Okay, so this is another identity we have to remember. R into NCR is equal to N into N minus 1 C R minus 1. Okay, so remember this property. R into NCR is equal to N into N minus 1 C R minus 1. Okay, now let's come to our theorem. So we have sigma of R is equal to 1 to N R into NCR, right? So that means I have R is equal to 1, that means I have N, sorry, I can write it as 1 into NC1 plus 2 into NC2 plus 3 into NC3 plus 4 into NC4 plus etc. plus N into NCN, right? N into NC. Now, using this identity, for example, 1 into NC1, we can write it as N into N minus 1 C R minus 1, right? That is 0, plus again 2 NC2, that is, again I can rewrite this using this formula, that will be N into N minus 1 C0, sorry, C1, plus the next term will be N into N minus 1 C2, this term will be n into n minus 1 into C3 plus etc. And the last term will be n into n minus 1 C n minus 1. Now if I take n outside, this will be equal to n into, because n is common, right? N into n minus 1 C0 plus n minus 1 C1 plus n minus 1 C2 plus etc. plus n minus 1 C n minus 1. Okay, and we know that this value is equal to 2 raised to n minus 1. So this is equal to n into 2 raised to n minus 1. Okay, so remember this, sigma of r is equal to 1 to n, r into NCR is equal to n into 2 raised to n minus 1. Now let's see the inclusion exclusion principle, and then after that we will solve some problems related to this idea. Okay, so it says the number of elements in A union B is equal to number of elements in A plus number of elements in B minus number of elements in A intersection B. Okay, so I know all of you know this, how this equation is derived, so I'm not going to explain all of this. So I'll just say that this we can extend. For example, A union B union C will be equal to, if you see, initially you'll have all these sets with terms of 1, right? A plus B plus C, then subtract, then you will have A intersection B, right, plus A intersection C plus B intersection C, right? So cardinality of these things, right? Then you'll have plus A intersection B intersection C, right? Now if you want to know A union B union C union D, then that will be equal to A plus B plus C plus D, right? That is, if you see, all are of size 1 basically. Then minus, you'll have the same A intersection B, right? Then A intersection C, right? Then you'll have A intersection D, B intersection C, all these things. Okay, then you'll have again a plus. Here you'll have with 3 sets. Okay, that is A intersection B intersection C plus A intersection B intersection D plus. So you'll have all these sets with 3. Then you'll have a minus. Then you'll have A intersection B intersection C intersection D. Okay, so this can be extended to any set. For example, if you want to see the number of elements in the union of I is equal to 1 to n ai, then the equation will be sigma of I is equal to 1 to n ai, that is of this type. Okay, then minus sigma of 1 less than or equal to I, less than or equal to j, less than or equal to k. Then you will have ai intersection aj. Okay, that will be of this type. Okay, so if you see this minus, next will be plus. You will have sigma of 1 less than or equal to I, less than or equal to j, less than or equal to k, less than or equal to n. So here should be n, sorry, n. Then you will have ai intersection aj intersection ak, that will be of this type. See, the plus and minus are getting symbol alternative. First term is plus, second term is minus, then plus, then the next term will be minus, right? Then plus, right? Then the last term will be minus 1 all raised to n minus 1, minus 1 all raised to n minus 1, a1 intersection a2 intersection up to a. So that will be the last term. Okay. So this is a general formula if we have to find out the number of elements in the union of n sets. Okay. Usually in exams, right, you may need 2 or 3 maximum. Okay. So just understand this is the general formula for n, and the terms, if you see, the plus and minus will alternate. In a class of 200 students, 125 students have taken programming language course. So let me represent it as P, that's equal to 125. Then 85 students are taking data structure. So D is equal to 85. And 65 students are taking computer organization. So let me call it the C, that is 65. Right? So what we know is P union D union C, right? That will be equal to P plus D plus C minus P intersection D, P intersection C, D intersection C, right? I have to say the number of elements, right? Minus plus P intersection D intersection C. So it's given that P is equal to 125, D is equal to 85, and C is equal to 65. Now, what is P intersection D? That is 50, right? So 50 plus this P intersection C, that is 35, right? 35. What's D intersection C? That is 30 plus 15 students are taking all 3 courses plus 50, right? So 50 plus 35, that is 85. So I can cancel this one and this one, right? So I have 30 here, so 65 here, so remaining will be 35. Then I have to add 50, right? So this will become 50, right? So total will be 125 plus 50, that will be 175, right? Now we have in the class, we have 200 students, and 175 students are there in this P union D union C. That means they are taking at least one of this course, right? So if I subtract, I'm getting 25. That means these 25 students are actually not taking any of these courses. So the answer should be 25. 25 persons are in a room. 15 of them play hockey. So let me have hockey playing persons are 15. 17 of them play football. So football 17. And 10 of them play both hockey and football, right? So H intersection F, the cardinality will be 10. Now what I know is H union F, cardinality will be equal to H plus F, right? Minus H intersection F, right? So that should be equal to 15 plus 17 minus 10, right? So that should be equal to 22. Out of these 25 persons, these 22 persons are actually playing at least one game. Okay, so that means 3 of them are not playing any game, right? They're not playing hockey or football, right? So the answer should be D. In a group of 21 persons, 9 eat vegetables, 10 eat fish, and 7 eat eggs, right? So I can write it as 9 eat vegetables, 10 eat fish, and 7 eat eggs. Okay, 5 persons eat all 3. Maximum, how many persons can eat at least 2 out of the 3 dishes? So we had to make it such a way that we need to have maximum persons eating at least two out of the at least okay, two out of the three dishes. So for this type of problem, right, better to draw the Venn diagram. So you have a set of people who are who eats vegetables. Then you have fish. So this is V. This is fish, and you have egg. Okay, so this is egg. Now it's already given that five persons eat all three. So we have five persons here. Okay, so this is five persons. Okay, five persons are here. Now total of people who eat vegetable is 9. So 5 is here. So this side I will have 4. Similarly, I have 10 people who eat fish. So 5 is already here. So remaining is 5. 7 people eat egg, right? So 5 is here. Remaining I have 2. Okay. So I need to have these portions that are the uh, portion having at least 2 out of the 3 dishes, right? So I need to have this portion filled maximum. Then only I will get the maximum number. So what I'm trying to do is I am just moving uh, 4 numbers from here to this intersection. Similarly, 4 numbers from here to this intersection. Okay, then only I can say they are part of both, right? So if I move from here, so remaining here I will have 1 person. Sorry, remaining here I will have 0 persons, and I have moved 4 persons to here. So remaining here will be 1, right? So now I have filled maximum here. Now if you see this portion, I have only 1 person remaining here, so I can move him here. So 1. So here also 1 person has to go here now, right? Because see, this is totally 2. Now you have 1 here. That means here you will have only 1, right? So that means now the intersection is having 5 plus 4, 9 plus 1, that is 10. So maximum you can have 10 people who are eating at least 2 out of the 3 dishes. In a classroom containing 28 persons, so we have total 28 persons. There are 18 who speak English. So English speaking persons are 18. Similarly, Hindi speaking persons are 15, and Kannada speaking persons are 22. Right? Now, what we know is the number of elements in E union H union K should be equal to E plus H plus K minus E intersection H plus E intersection K plus H intersection K plus E intersection H intersection K, right? So that means E union H union K cardinality will be equal to 18 plus 15 plus 22 minus E intersection H is given as 9 plus 11, right? 11 plus 13 plus E intersection H intersection K. I think this is the value we need to find out, right? This is the value we need to find out. But if you see, we also need to know this value. It is all not given, right? So ideally we cannot proceed, but I think we have to take an assumption here that um, every person actually can speak at least one language. Okay, so that is assumption. If you are taking, then we can say that all persons can speak at least one language, English, Hindi, or Kannada. Then this value should be equal to 28, right? Then we can proceed. Okay, so if this value is 28, then this value will be, if I add all this value, I will be getting 55 minus this value, that will be 33 plus this is the value we had to find out, right? So let me call that as x. So x will be equal to 28 minus 55 plus 33, and that will be equal to, so the answer should be D. What is the cardinality of the set of integers x defined below? So we had to find out the cardinality of x. X is equal to n, and n is greater than or equal to 1 and less than or equal to 123, comma, n is not divisible by either 2, 3 or 5. Okay, so basically x contains set of all integers greater than or equal to 1 and less than or equal to 123, which are not divisible by 2, 3 or 5, right? So we have total 123 numbers, that is 1 to 123 numbers, right? And let's assume we have x numbers that are divisible by 2, 3 or 5, that are divisible by 2, 3 or 5, then which are not divisible by 2, 3 or 5 will be equal to 123 minus x, right? So basically we have to find out the value of x, then subtract that with 123. Okay, now let me see the numbers which are divisible by 2, that let me call that as A, and numbers which are divisible by 3, that set is B, and numbers which are divisible by 5, we call that set is C. Now I know that cardinality of A union B union C, that is what, or x, right, will be equal to cardinality of A plus cardinality of B plus cardinality of C minus cardinality of A intersection B plus cardinality of A intersection C plus cardinality of B intersection C plus cardinality of A intersection B intersection C, right? This will be the answer. This will be the value of x. Okay, so A is the numbers between 1 and 123 that are reduced by 2. So we can just say 123 by 2, that will be 61, right? So we'll have 61 such numbers which are reduced by 2. So I can say 61 plus. Now number of the numbers which are reduced by 3 will be 123 divided by 3. So that will be 41. So we have 41 such numbers plus the numbers which are reduced by 5, that will be 123 divided by 5. So we'll have 24 such numbers. So we'll have 24 here minus, what is A intersection B? That is the numbers which are divisible by 2 and 3. 2 and 3. That means we had to find out numbers which are divisible by 6, right? 2 and 3. That means we had to find out the numbers which are divisible by 6. That will be 123 divided by 6, right? So we'll have 20. So that will be 20 plus number of integers less than or equal to 123 which are divisible by 2 and 5, that will be 10, right? So that will be equal to 12 plus numbers which are divisible by B and C, that is 3 and 5. That means we have to divide it by 15. So 123 divided by 15, that will be equal to, should be equal to 8. So we have 8 here, right? Plus numbers which are divisible by 2, 3 and 5, right? So we had to see numbers which are divisible by 30. So we'll have 4, right? So this should be the value of x. So x will be equal to 126 minus 40 plus 4, that is equal to 130 minus 40, that is equal to 90. So we got x is equal to 90. That is the number which is at least divisible by 2, 3 or 5. So we had to find out which is not divisible. So I had to do 123 minus 90. So that will be 3 here, 3, right? So it will be 33. So the answer should be B.